to my second Unity tutorial video, Making Things Move. Today I am going to be talking to you about basically intro to scripting in C# and how to get things to move around either with player input or by themselves. So first off, I want to show you a really great tool that I use certainly a lot for when I have coding issues, and that is the Unity documentation, specifically the scripting API. This is an amazing reference specifically for Unity. As you can see, it has both C# and JavaScript for any of the examples, and it basically shows you what the function that you're using does. It shows you how it's how it's supposed to be used, different overload functions. For example, let's say we wanted to do on trigger enter. If we search that here, you get a huge list of all of the different on trigger enter functions that you could use, as well as things related to it. So if I clicked on the first one, it would give me a description of what happens, a more in-depth description, any special notes, and an example of how to code this in either C# or JavaScript. It also gives you an example of what it looks like up here, especially with the types you need, for example, collider, and basically stuff like that. It's a really great tool to use. It has everything that you need. I'm using version 5.6. This is the beta version. I just keep it on this one because that's the one we're using. But yeah, so the Unity documentation, the scripting API is a amazing sorry, let me try that again. It's a amazing place to go if you have any questions about scripting. And you just need something answered really quickly. Also, you could just go ahead and search stuff up, like let's say I want to know how to make my character jump, and then I just say Unity C#, and places like answers.unity3.com, Stack Overflow, I know it's not here, but if you basically search Unity and then C# along with your question, you're going to get some answers that are pretty amazing. You have to make sure you check what date they're from. This is from October 14, 2010, so the code might be a little bit different, but the methods and the thought process behind it is going to be pretty much exactly the same. For example, here we're just going to have this guy has an awesome answer. So is this guy. This guy says basically the same one or the same thing, but he formatted it in form of actual code, so you'll be able to use this to understand what's going on. And let's say you don't know what the function translate does. You can go over to the scripting API, search up translate, and you can see exactly what it does, the kind of overloaded functions it takes, different ways to do it. It's pretty great. Basically, you have an insane amount of information here for you to look at and see, how to make everything work. So now that we have that, we are going to come back to our test project that we have created before, and we're going to put all of this into action. We're going to make all of this work together now. So first, now that we've talked about introduction to scripting and different places where you can find it, we are going to actually script our object. Just for simplicity, I'm going to put us in 2D mode so we can see our red square moving left and right. And that's the first thing we're going to be doing. So first I'm going to click on this cube, and it's going to open up its properties in the inspector mode. There are two ways to make code. First way is you can right click in your projects window, go to create, and then create a C# script up here. Or if you want to apply it directly to the cube, you can go add component, go down to new script, make sure it's in C#, and then name it. We're going to name this basic movement. There we go. Something to note is that in these file names you cannot have any spaces, because basically the way it works is, so right now, as you can see, we have basic movement. I'm going to create an add. The file name is going to keep it as basic movement, and inside of the program it's going to say basic movement as well. If I created something that had a space in the name, let's say new movement, that has a space now, it's still going to say new movement here, but in here there's not going to be a space inside of the code, so it's going to mess everything up. So just so you know, no spaces in the file name. If you want to have spaces kind of like that, you can rename it by double clicking on the, or not double clicking specifically on that. It's a little finicky. You can rename a bunch of stuff that way. But you can either double click and rename it. I would really recommend just completely deleting the file and starting over. It would save a lot of hassle in the long run, and Unity sometimes gets a little confused if you don't have the exact naming down. So we're going to wait for Visual Studio to open, and then we're going to continue after that. So now that Visual Studio is open, we can see that the file that I've opened, basic movement, in case you didn't see, I deleted the other one and now I opened a basic movement here. Basic movement is now open, and this is the generic system, or not the generic system, the generic template that Unity has given your C# file. I'm just going to explain what all of this means really quick, and then we can hop right into code. So the stuff up here is your basically the stuff that you're going to be using. You're not going to be importing, or I mean, you're going to be importing other stuff, but for now, don't delete any of this. This is basically instructions telling the computer what kind of things you want to use. So you can add stuff to it, but I would not recommend taking stuff away until you really know what you're doing. Here, this is the main header for your entire thing. This is basically the start of your file. And then here is, it says start. So use this for initialization, and update is called once. So these comments here, // is how you create a comment. These comments tell you what they do. So start is only called as soon as the object that the script is attached to enters the scene. It's only called once, and it's never called again afterwards. So you're going to want to call this, for example, if you, let's say you spawn into a world and you have your game master, and on your game master is this script, and then for that you would want your, let's say, your character and your enemies loaded into the scene immediately. So you would put all of the initialization and making sure they come into the scene under the game master's start area. Update, as you can see, is called once per frame. Usually games run at about 30 to 60 frames per second. Basically, you're just going to be using update if you want it to be happening every single time, if you want things to be happening, or if you want like checks to be happening every single frame, if you want frame perfect checks and stuff like that. You have to recognize that if you put stuff in update, it's going to be called every frame, like it says. So you shouldn't have a lot of really intense, like hardware intensive code inside of your update function. Your update function should mostly be for checking variables, or for just making little checks that aren't going to be super intensive on your computer. You don't want to be generating the entire world in your update function, because then if it runs every single frame, it's going to be regenerating the world every single frame, and that's just going to be too much for your game to handle, and it will chug. So in order to avoid that, you're going to be creating a separate function that basically is called from the update function to see if it can actually move and stuff like that. But that's going to be stuff later on. I'll get into that in a couple of other videos. But for now, just know that since games have to be really fast, They need to be really responsive. You don't want a lot of high octane stuff inside of your update function, since it's going to be called every frame. So now that I've explained the basics of the general setting that Unity gives you when you open up a C# file, we are going to make a very simple script to make our red ball, or red square, sorry, right here, and we're going to make it move left. So in the update function, since we want this to happen pretty much as soon as the game starts, we are going to put in the code to make this square to move left. So we're going to say transform, and what transform does is it starts the ball. It starts the ball rolling for all of the specific movement functions. So after saying transform, we're going to put a period. And as you can see, Visual Studio as well as MonoDevelop, if you're using that, has this huge list of things that you can put afterwards. These are all valid identifiers or functions that you can put after your transform. So we can scroll down and try to find translate, or we can type it in. So let's say, and I know translate is a capital T, so you're going to place capital T, and it's going to jump to the to this area. So now that we know that it's going to be transform, we're going to find translate right here. We can also continue to type it out, but if we want to complete it right now, since it's right there, we're just going to press tab, and it's going to auto-complete it. So after doing transform.translate, we're going to put another dot. So translate basically means it's going to be moving slowly instead of jumping to the position. If we wanted to learn more about this, we can go to the scripting API, because we have transform.translate here, and we have examples of it here. So we're going to use this one really quick. We're going to do transform.translate vector3 and then the time. Up here, it tells us what it's looking for. So we're going to do vector3. So let's just make a new vector3. Now, vector3, as well as vector2 being for 3D, vector3 being for 3D, has a couple different ways that you can use it. Vector3, you can use it as shown in this documentation with forward, up, etc. Or you can use parentheses to basically create a exact movement pattern. For example, because if you, let's say we just went to vector3 dot, that's not a dot, left. That is not a dot either. Okay, come on, L-E-F-T. There we go. So if we did vector3 dot left, it's going to move to the left, and you can see right here it tells you what it says. It's shorthand for writing vector3 -1 0 0. But let's say we didn't want to move -1. Let's say I know for a fact that -1 is going to move across the screen super fast, so we want it to be -0.1. So we're going to put parentheses -0.1 0 0. The other zeros being for the y and z coordinates. Now if we wanted to learn more about this, we can click on the hyperlink for vector3 in the documentation, and it will show us all the different functions that can be used for that. We have back, down, forward, left, 1 being just 1 in every direction, right, up, and 0 for moving 0. We also have variables, constructors, public functions. It basically has everything that you would need for writing this. And we're using the type that isn't static variables. We're using fluid variables like this, where we get to assign it ourselves. So now that we do that, we're going to go back to our main documentation. We're going to see, okay, what's next? Where we need either time, or so we have that. We have our translation, and it's also asking us for space. Now, the space is interesting. You don't need that, as you see in this one. This one does not have space. Space could be relative to the actual spot. So if it's relative to the world, which it is by default, then it's going to move in the X, Y, and Z direction of the actual world. However, you could set it to be relative of something else. Like for example, if you wanted, let's say your character is holding a sword and you want the sword to move 3 units away from your character, well, you don't really need to calculate exactly where the character is in the world, and then calculate, 3 blocks away from that character and then move the sword to that position. You could just make the sword relative to the parent or to the character, parent being the one holding the object, and then move it 3 there. And then we can press Shift Control B, and this will build the file. So as you may have noticed, there is this red squiggly underneath vector 3, and as this is building, you can see down here by build started, it should build at some point, we're going to get an error for this. If you hover over it, you can see that it gives us an error of a non-invocable member vector 3 cannot be used like a method. So this is a problem in a lot of coding where you think something's going to go right, but it doesn't go right because you have no idea why. Yeah, so welcome to coding. This happens a lot, get used to it. And we're basically now just going to go back and see what went wrong. So looking at this, it seems like we can only use vector3.forward or vector3.up just when it's used like this. However, if we scroll down the page, we can also see that things like this happen, where we can put in the exact coordinates instead of needing a vector 3. So we're going to do that now. We're going to remove vector 3, make sure to remove the extra parentheses, build it again. Oh, that's my fault. Any decimal points, you need an F afterwards. F being the signal for float. I forgot to talk about that. So any decimal points need an F. Any single numbers don't need an F. So now we have no error, and it works. It has been built. So now something is going to happen when this is now in the scene. So if we go to Unity, we can see that it, depending on how big the thing is, it would load for a bit, but it already loaded. We're going to go to our cube prefab, and we can either add component or we can just drag it on. And now we have our basic movement script attached to the object. Since we did that in a prefab, it's also going to be on here. Go ahead and we're just gonna remove this because I put 2 on by accident. But now if we look at the cube, we have our basic movement script on it. We also have our rigid body. I'm going to remove this rigid body for now, just so that we can see how it works. Another way to do that is just to click the box, checkmark box. That's going to toggle the component on and off if you don't want to fully delete it. But anyway, I think now, after saving the scene, we can actually try it and see what happens. We're going to maximize on play to get the full effect of this, and let's watch. And there we go. It moved to the left. Congratulations, you have now made something move. Now we are going to unmaximize this so we can see it as well in the scene to see what's happening off camera. So this, you just keep on going. If we look here, it's increasing by 1 every frame, and it's just going to go on forever now. So let's stop that. We're going to zoom in a bit by pressing F, and we're going to go back to our script. Now, how great would it be if it started moving right after it went off screen? So we're going to go up to here again. We're going to play. We're going to play it. And we're going to wait until it gets off screen. That's about where it got off screen. I pressed the pause button to either pause it, and you can press it again and unpause it if you didn't want to fully go back and see, where it was. So we ended with, and let me just do this again. It goes off screen right about at -8. So we're going to stop playing that, and we're going to go to our code, and we're going to say, okay, we want it to, I'm going to comment here so we can make some pseudocode. We want it to move to the right after reaching x equals -8. So that's what we want to happen. And then just for the sake of making it an infinite loop, we're going to say we also want to move it to the left after it reaches x equals 8. And just to check to make sure our camera is at 0, 0, there we go, because if it was at a different position, then obviously we would need to offset our positioning to make sure that it stays on and off screen at all times. So now we have our pseudocode of what we want to happen. We have our actual code of how to make it move. So now we're going to start doing some tests. So down below, and press enter twice. We can forget about this now. We're going to comment this out, and we're going to say that this is the actual code needed. So I can copy and paste that for later. So, okay, in the update function, we want to say if we are going to use this, so you need to be careful about using this because in Unity, what this, as in the letters, mean is it's referring to the actual code. So you can use it in place of the object, but it's better style to use this dot game object because now this is talking about the actual game object and not the actual script. So after doing this dot game object, we can do dot transform dot position dot x, and what this does is it's giving us the position, the x coordinates of the game object, and we're going to say equals, and we want it to be -8. So if it is equal to, well, actually let's do if it's less than or equal to -8, then what we want to happen is curly brackets. That shows in C#, that's how you basically, geez, I am great with words today. Curly brackets is how you designate different sections of your code in C#. So now that we have that, basically that test, it's going to be testing that every frame. It's going to say, okay, well, is the game object, is the x position of this game object less than or equal to -8? If that is correct, then we're going to want to move it to the right. So now we're going to do this, and we're going to copy and paste that into there. Now, what we're going to want to do is we're going to do else, and then we're going to do the same thing, where let's put some curly brackets on that. Else, we're going to paste that, but now it's going to be in the positive direction. Actually, these should be flipped. So what's going to happen here is it's going to check to see if it's less than -8, and then it's going to go forward, or I should say to the right. If it is not less than -8, then it's going to go to the left. Now, some of you might be thinking that this works, and it does work. The code does run. We're going to press Shift-Control-D to build it, but it's not going to work the way that you think it will. Let's go ahead and look into Unity to see what happens when we play this. So what happens here is if we look at the cube in the inspector, it is constantly staying between -8 and -7. What's going on is inside of the code, we have when it starts, it's checking to see if it is less than -8. It's not, so it's going to go to the else statement. Then it's, and since it's in the else statement, it's going to keep going to the left. Now, once it reaches -8 or it's less than -8, it's going to go to the right. But as soon as it's not, as soon as it is above -8, like as soon as it's -7, -6, etc., it's going to move back to the left, or it's going to move back to the left. So all this does is it sends it to the left, and then it's going to jitter back and forth because that's what the code's telling it to do. So we need to be a little bit smarter with how this works. So what we're going to do is we're going to create two variables called, we're going to create two booleans using bool, and these are going to be called, we're actually going to create one variable called direction. So we're going to put this up here above all the other stuff because it needs to be a global variable, so so that the entire code can use it. We don't want to put this in the update function because then it's going to create a new variable every single time it will be used, and we don't want that. So basically what's going to go on is when it is less than -8, we want it to go left, or sorry, we want it to go right. So we are going to designate up here, oops, yeah, triple thing does a summary. We just want it's a simple double, and we're gonna say true equals left and false equals right. So if it is to the left of -8, we want it to go right. So we want to say direction equals right, false. Since up here we've designated the false equals right. That's just a single quote. And then in here, we want to say direction equals true. But we need to set this, up again, because now it's going to do the same exact thing once we finish the rest of the code. So we need to say, instead of else, we're going to do else if. Basically what this does is it says if this, then else this. It's like if this is false, then it's going to do this, but only if this is true. So it's going to say, we're going to do the same thing now. We're actually going to copy and paste this, and we're going to make that a +8. So now what this is saying is if this game, so it's saying if the game object is less than or equal to -8, or so if it's left of -8, then it's going to do this. But if that's not true, and it is to the right of 8, then it's going to do this. So basically, I hope that explains it. If we just had a normal else statement, then it would run every time. But by having an else if, it adds an extra variable to it so that it won't run every single time. So now that this is happening, we want to basically make it continue going left, make it continue going to right, etc. while this is happening. So down here, underneath the if and else ifs, we are going to make another test. We're going to say if direction is equal to false, not false, false. And by the way, if it's a test, it's double equals, but if it's just an assignment, it's single equals. So if the direction is equal to false, or if we want it to move right, then down here, we are going to copy and paste this, and we want it to move in the right direction, which is going to be +0.1. And the semicolon to end off the line. And then we're going to say else, because we don't care if it goes, if this continues while direction is not false, we're going to copy and paste the same thing, and we're going to keep that as -1. So now what's going to happen is it's going to basically check. First off, we need to assign this a variable at first, because it's not going to know what to do at first. Or what we can do is under start, we can say direction is true. So what's going to happen is as soon as the game starts, it's going to set direction equal to true. And now it's going to come down here, and it's going to say, okay, well, is it less than -8? No. Is it greater than -8? No. So none of this is going to happen. So now it's going to come down here, and it's going to say, okay, is direction equal to false? No. So if direction is not equal to false, then we are going to make this go left. So it's going to go left, and once it reaches that, it's going to set direction to false, or right. So now after that's done, we're going to go down to here, and we're going to say, okay, is it right? Yep, and it's going to keep on going, and hopefully what this does is it's going to create a loop where the ball is going to bounce, or the square is going to bounce back and forth off screen. So let us try that. There we go. That's how it works. We're actually really quick, just so that you can see this in the full glory. We're going to reduce this from 8 to 6 so that we can show this in maximize on play mode. And you'll be able to see exactly what's going on. There you have it. So you may have noticed that it's coming this way, and we can see the side of it, but we cannot see the side of the other one. Not entirely sure why that's happening. So, because our main camera is looking straight ahead, and if we play this, we can see that the angle would be giving it to us on this. You know, it should let us see this. However, I think the problem is our directional light is at a weird rotation. If we look at that, the light is shining in this direction, so we wouldn't actually be able to see anything on that side. If we want to see it on that side, let's set the rotation to 0, 0, and play it from there. So now we can't see either of the sides, but that's because the light is shining directly on it. If we didn't maximize it, and I showed you the directional light turning, you can now see that side, and the other side's completely dark. But if I turned it away, that side goes black, but now you can see this side. So you have to make sure you know what your light's doing, because sometimes you might think that a side isn't there, but it is there as a matter of fact. So there you go. So that is a really basic movement script. Right now we just have it bouncing back and forth forever. But let's say we want the player to control it, right? You don't want everything to be moving on your own in most games. So let's say we want the player to control whether or not it's going to go left or right. So what we're going to do is we're going to do backslash and asterisk, and then we're going to do asterisk backslash. And what this does is it creates a giant commented block so that we still have it, but none of this is going to run. And then underneath the update, now we're going to say, we're going to use a very special bit of code that designates whether or not the player is trying to influence the object that it's supposed to be controlling. We're going to say if input with a capital I dot get, let's do, well, okay, so there's get button and there's get key. So get button will give you need to use exact button names, but if you use get key, this this will allow you to get certain keyboard stuff. You know, this will get this will allow you to use actual keyboard letters and letter names, while using get button is stuff that you have to actually input yourself. So we're going to be using get key. So we're going to say if input.getKey, and then you need the name for it. So we're going to do get key A, capital A. So basically something's going to happen while while the button A is being pressed down. Now we are going to want to copy and paste our movement. Oops. Copy and paste our movement. So it's going to be moving left while the button is down. We can copy and paste the same thing for D. And now there we go. We have input being the player, basically checking to see if the keyboard is being pressed. And if we go into the game, it's not maximized, we can now control it. Oh, that is my fault. So down here, it says input key named A is unknown. So we're going to go back to here, and we are going to be using we're going to be using lowercase letters. How about that? Build succeeded. We're going to come back here, we're going to try it, and we're going to see if the console gives us any exceptions. No. So you need to use lowercase letters. So now we're going to press A, and it's moving left, D moving right. So there we go. So now we have player-controlled movement. And that's how it works. So now we've just done one-dimensional movement, right, left and right. Let's say we want to do two-dimensional movement. Let's say we want to add up and down. We're going to do basically the same thing. We're going to copy and paste this 2 more times. And we're going to say W and S. And we're going to set the X to 0. W needs to be up, so we're going to do 0.1 F for up. And this is going to be negative 0.1 F for down. Set this to 0, Control-Shift-B to build it. Come over to Unity, it's going to load in, and we press play. And now we can control it just like so. There you go, you have full player-controlled movement of the object, both up, down, left, and right. So now you have created two-dimensional movement. Now, three-dimensional movement is a little bit harder to do. It's not something that you can do in a 2D setting like so, but I would recommend using Q and E if you wanted to do that. Well, I mean, why not do it, right? This is a tutorial. We'll just do it anyway. So let's do Q and E. We're gonna make Q be the forward for 3 dimensions, and we are going to make E be the backwards of 3 dimensions. Ooh, that's not correct. There we go. And let us try that out. So now we have our 2-dimensional movement like so, but we also have 3-dimensional movement by moving it back and forth. As you can see in the scene, by the way, if you click in the scene to do something and you want stuff to happen again, you need to click that in the game. And now we have a movement, and it's going further away. And it's getting closer, you can move up and down, and it all works. So there you go. You have created 3-dimensional movement in a 2D space, and it's pretty awesome, and it's only 2 lines of code. So there you have it. That is the basics of 2D movement. We've even created some 3D movement, and that is basically how things move. In the next video, I will be showing you how we're going I'm going to be showing you how to actually start the game that I will be leading you on, and then you'll be able to really start making games with all the information that you know. So I'll see you next time.